Hello everyone. Today we are talking about hash functions. If you have not seen my previous video where I talk about the more practical use of hash functions in password hashing, you can watch it by clicking on the top right corner of the video. If you have already seen it, the first minute or so of this video will probably be very familiar to you. Hash functions are one-way functions. That means that it is only possible to calculate outputs from inputs and not the other way around. If I have any input, for example a password, and I apply the hash function to it, I receive some kind of output. If I now want to reverse the operation and try to get the input from the output, this will fail because of the one-way property. This property is called pre-image resistance, as it is not possible to find the pre-image to the calculated hash. That's why it is so useful for storing passwords. If you enter a password at some site, it will get hashed and only the hash value is stored on the server. Note that this only works because the same inputs always produce the same outputs. There are various hash functions out there, and most of them are fine to use. However, don't use MD5 or MD4 for that matter. I will explain why at the end of this video. First, what do we use hash functions for except for password storing? Hash functions are used to grant integrity and authenticity. Authenticity is done, for example, via digital signatures, which you can watch a video about if you click on the link on the top right corner. For integrity, we can look at an example you might encounter in your internet life. If you download a file, you will sometimes notice that the website also provides you with a hash value of the file. If you download the file, you can calculate the hash yourself using either internet tools or pre-installed tools. And make sure to use the same algorithm as has been used by the provider of the file. They should tell you which one they used. If you calculate the hash, you can now compare it to the one that is posted on the website. If they match, you can be sure that the file is in fact the file that was offered. If, however, the file has been tampered with either in transit to you or during any other stage of the download, you will notice that the hashes do not match, as even small changes to a file will drastically change the hash. In that case, you should not execute the file, as there is a potential for malware within the downloaded file. So what does a hash function do? It takes an input of arbitrary length, meaning passwords are equally as possible as inputs as huge files, with multiple gigabytes, and produces a hash of fixed length. No matter how large or small the input, the output is always the same size. A good hash function should provide different outputs for different inputs. In our example, however, we see the two inputs, in this case input B and input C, produce the same output. This should not happen, and is indeed the second important property of hash functions. There should be no way to find a second input or pre-image to a given pair of input and hash. This property is called second pre-image resistance. That means the algorithm is resistant to finding a second pre-image to a given pre-image hash value pair. An even stricter requirement is closely related but still different. A good hash algorithm should also not allow you to find two arbitrary inputs that result in the same hash value. This property is more strict, since you are more free to find any values you like. This property is called collision resistance, as the hash function is resistant to finding two pre-images that collide, meaning that result in the same hash value. To summarize, the three properties of a good hash function are pre-image resistance, meaning I cannot find the input from a given hash output; second pre-image resistance, meaning I cannot find another input to a given input hash value pair that results in the same hash value; and collision resistance, meaning I cannot find two inputs that result in the same hash value. This brings us to MD5 and why it is depreciated nowadays. Pre-image resistance holds, but there is a theoretical attack that could break it. Second pre-image resistance holds, there is no attack yet on it. Collision resistance is however broken. Mind you that this does not necessarily mean that everything that's hashed with MD5 is now completely unsafe. But the limited size of the hash value, 128 bits, means that it is probably only a matter of time until all the theoretical attacks become practical. So you should use better and more modern hash functions, such as, for example, SHA-512, in order to be safe for a lot longer. That concludes today's video. Thanks for watching. Tell me in the comments which topics you would like me to cover, like and subscribe to the channel, and see you in the next video.